Hello students. Okay, section 4.1 is on inverse proportion and a type of function called a rectangular hyperbola. So let's get started. Okay, what I'd like you to do right now is to pause the video, read through the question, and try to complete the table and write the two equations. So pause the video now and start it up once you've done that. Okay, let's see how you went. So, a car travels at a constant speed for a distance of 120 kilometers. So if it's traveling at 10 kilometers an hour, it's going to take 12 hours to complete the journey. And if it's going at 30 kilometers an hour, it's going to take 4 hours, and so on. So that's the table that you should have completed. Notice that as the speed goes up, the time goes down proportionally. So as the speed doubles, the time goes down to 1/2, and that's what inverse proportion is all about. If you want to write an equation for time, this is what you should have come up with. Time is 120 divided by speed. So in other words, 120 divided by 10 gives 12. 120 divided by 60 gives 2, and so on. And you can rewrite that equation to make speed the subject. So if you've got 4 hours to travel, 120 divided by 4, that means you've been traveling at 30 kilometers an hour. So there's two different formulas that you can get from that particular question. Okay, so before we talk about inverse proportion, let's just remind ourselves about direct proportion. So here's an example of direct proportion. Distance equals 60 times time. So let's just say that we're talking about distance in kilometers, time in hours. This is of the form y equals kx, where k is a real number. In this case, k is 60. And as time increases, distance increases proportionally. So for example, if time is 1 hour, you travel 60 kilometers. If time is 2 hours, 60 times 2, you travel 120 kilometers. If time is 10 hours, you're going to travel 600 kilometers, etc. So that's an example of direct proportion. Effectively, it's a straight line equation that passes through the origin. Inverse proportion, instead of multiplying by a number, you divide. So instead of multiplying by t, you divide. In this case, we've got time is inversely proportional to the speed. So as the speed goes up, the time goes down, and vice versa. So if the speed goes down, the time goes up. So that's an example of inverse proportion. And note that if I multiply both sides of that equation by s, another way to write the equation is like this. Oops, I want to write that in red. Let me try that again. Time times speed equals 60. So this is actually a useful way to sometimes write your inverse proportional equations. Okay, so you might just want to jot down this. The name of that formula is a hyperbola. The full name for it is a rectangular hyperbola, but I just call it a hyperbola. I haven't come across too many non-rectangular ones. So y equals a over x, where a is a constant. Okay, let's have a look at a few questions. You're not going to find these particularly difficult. So the time taken to paint a mural on a large wall by n painters is given by the equation t equals 36 on n. So if you have 9 painters, how long is it going to take to paint? And fairly obviously, I hope, there's your formula that I copied from the question. And if you have 9 painters, the time is going to take 4 hours. I should have put the units on that, so I'll go ahead and do that right now. And for question B, Determine the number of painters required if the mural needs to be painted in 10 hours. Well, have a go at that. Stop the video. Have a go. This one actually has a little bit of a twist to it, so try it first. And there's a couple of ways you could do this, but what I'll do is start with the same formula. Substitute 10 for t, because that's the time that we have. I've got to solve that equation for n, so I can multiply both sides by n and divide both sides by 10. But that's not the answer. Not quite. The reason, of course, is you can't have 0.6 of a painter. So in order to get the job done, you always have to round up. So in this case, the answer has to be we need 4 painters. You can't have 3.6 painters. Okay, let's move on to the next question. Question 5 from the textbook. Soluble vitamin tablets often dissolve quicker when the water is warmer. Sean dissolved some vitamin tablets in water at different temperatures, T degrees Celsius, and measured the time in seconds it took for one tablet to dissolve in a fixed quantity of water. Determine the rule of the function connecting capital T and lowercase t. So again, stop and have a go at this yourself, and then restart once you think you have the answer. Now, one thing that you need to realize is that times that, that times that, and that times that all have the same answer, which is 960. So that implies that we can write the formula is capital T times lowercase t is 960. And then we can rewrite that to make either capital T or lowercase t the subject. Now, if you look at the table up here, normally the independent variable is in the first column and the dependent variable is in the second column. So this table implies that the time that it takes to dissolve the tablet depends upon the temperature. So in this case, you actually want to solve for little t rather than big T. And that's the formula that you should have come up with. Okay, let's move along. And this is the last one we're going to do as a for this video. As a piston is pushed down into a cylinder, the volume decreases and the pressure increases. The pressure P inside the cylinder is inversely proportional to the volume. If the volume in the piston is 9 cubic centimeters, when the pressure is 0.3 PA, whatever that represents, determine the pressure when the volume is 20 cubic centimeters. So once again, pause the video, have a go yourself, and then check to see how you went once you've done that. Okay, so pressure is inversely proportional to volume. As the volume goes up, the pressure goes down, and vice versa. Put in the numbers that you know. So you know that P equals 0.3 when V equals 9. And solving that for A, we multiply both sides by 9, and we get A equals 2.7. And therefore, that's the formula. Pressure equals 2.7 divided by volume. Okay, the question now is determine the pressure when the volume is 20 cubic centimeters. So that's just a matter of subbing 20 into the formula, and I come up with 1.35 units being PA, whatever that represents. And that is the start of the section, the exercise 4.1. We'll be moving on to some slightly more tricky questions in the next video.